Okay, today I want to share with you just the slight difference we have in yesterday's method when we revolve around a different axis rather than just the x and the y. So here we have a solid that's formed by x squared, y equals 0, and x equals 2. So again, I really want you to sketch those things out. It does actually make the process a lot easier. So here we have our function x squared. Here we have a line representing x equals 2. And of course, y equals 0 is that axis down there. So we're taking this region and we're revolving it now around the line x equals 3. So I'm going to draw that vertical axis in a dotted line. And I'm going to make sure I indicate that we're revolving around that line. Okay, so you can see that this is going to have a hole in it because our region is not connected to the axis of rotation, so there will be a hole, and anytime there's a hole we have to use the washer method. So let's talk about big R and little r. First, we should realize that our functions here, if we are revolving around a vertical axis, we need to have everything in terms of y. So my integral is going to be in terms of y. So I need this equation, y equals x squared, solved for x. So that is actually going to be a square root y function when we talk about it over here. Big radius, friends, big radius always goes from axis of rotation out to the farthest away function. This is where we find big R in this example. Okay, right there in yellow, that is our big radius, from axis of rotation to the farthest away function. How are we going to write that as an equation? It is super duper important that you realize this whole distance is 3, and this distance that's not covered by our solid is square root of y. Remember when we changed that over here? That distance is square root of y. So our large radius is going to be this whole distance 3 here minus this little root y. So 3 minus root y is our large radius. Okay, the small radius is always found by starting at the axis of rotation and going to the nearest function. So here I drew that in blue. Our little r is right here in this blue color, axis of rotation to the inside function, or the closest function. And that, because we're going from x equals 2 to x equals 3, we know that radius is a constant value of 1. Okay, once you identify those two things, and that will be the hardest, trickiest part, once you identify those two things, the rest of it's kind of easy peasy. Okay, we know from yesterday the washer method takes big R, so 3 minus root y squared, minus little r squared. And our limits of integration are from this point down here, which is 2, 0, to this point up here, which is 2, 4. So we're going to integrate with y values 0 to 4. This is a pretty messy function to integrate, so I earlier typed that into my calculator to get an approximation of, oh, that was bad, 25.133 for a volume of that very strangely shaped object. Again, the inside and outside radii are going to be probably the trickiest part, because once you have those, plugging it in, or even integrating, super simple. So draw your pictures, find your big R and little r, and everything after that will be super fun. Have a great day.